In this video, we'll prove that integral of secant of x dx is equal to ln of absolute value of secant of x plus tangent of x plus c. Let's begin by rewriting the integral again. So integral of secant of x dx. The definition of secant of x is 1 over cosine of x dx. So I'm writing it like that. And then starting from integral of 1 over cosine of x, I'm going to multiply the numerator and the denominator by cosine of x over cosine of x, which means I'm not changing my function, as cosine of x over cosine of x is 1. So when we multiply the numerator, we get cosine of x, and when we multiply the denominators, we get cosine squared of x dx. Now we know from the trigonometry that sine squared of x plus cosine squared of x is 1. So we are going to replace the denominator by 1 minus sine squared of x dx. Let's use a trigonometric u substitution. U equals sine of x. Du is cosine of x dx. So going back into our integral, the integral becomes du over 1 minus u squared, which, using the difference of two squares, the denominator becomes 1 minus u times 1 plus u. So, in order for us to compute this integral, I'm going to use partial fractions. So, 1 over 1 minus u times 1 plus u can be separated into a over 1 plus u plus b over 1 minus u. I actually wrote the positive one first. And it's okay, multiplication is commutative. Now I'm going to multiply by 1 minus u times 1 plus u. And I'm going to get 1 over, on the left side, and on the right side a times 1 minus u plus b times 1 plus u. So if we set u equals to 1, we get 1 equals 2b, or b is 1 over 2. And if u equals negative 1, we get 1 equals 2a, or a equals a half. So going back into our integral here, we are going to have integral of a, which is a half, over 1 plus u du, plus integral of b, which is 1 half, over 1 minus u du. The constant comes in front of the integral, and then we get 1 over 2, integral of 1 over 1 plus u du, and then plus 1 over 2, integral of 1 over 1 minus u du. The first integral is ln of absolute value of 1 plus u. And then the second integral, so I have 1 half, but because I have negative in front of u, is going to be negative 1 half ln of absolute value of 1 minus u. So just imagine if you did this a new substitution and you said that's a v, 1 minus u is v, dv is negative du, so that's why we get a negative in front here. So now if we factor out 1 half, we end up with ln of 1 plus u minus ln of 1 minus u. We know from properties of logs that ln of a minus ln of b is ln of a over b, so it's 1 plus u over 1 minus u. And we're going to use the substitution back. U equals sine of x, so we get ln of 1 plus sine of x over 1 minus sine of x. But let's not forget, plus c, but let's not forget that our goal is to prove that this is our final answer, ln of absolute value of secant of x plus tangent of x. So we are going to write 1 half ln of 1 plus sine of x over 1 minus sine of x, and I'm going to multiply top the numerator and the denominator by 1 plus sine of x over 1 plus sine of x. Again, I'm not making a major change to my expression because 1 plus sine of x over 1 minus 1 plus sine of x, it's 1. And then, when we multiply the numerators together, we're going to get 1 plus sine of x squared. I'm not going to expand. And 1 minus sine of x times 1 plus sine of x, it's 1 minus sine squared of x because of a minus b times a plus b. So now, the numerator, I'm going to keep it 1 plus sine of x squared. And the denominator, it's cosine squared of x. We've used that formula before, and it's in absolute value. So we get ln of 1 plus sine of x over cosine of x, everything squared. I'm going to continue writing the absolute value. I'm not writing the c anymore. I can write it only at the very end. I know a property that logs has when we have ln of an expression to a power, the power comes in front. So it's 1/2 times 2 ln of 1 plus sine of x over cosine of x in absolute value. 2 and 2 cancels. And we end up with ln of absolute value of 1 over cosine of x, it's secant of x, and sine of x over cosine of x is tangent of x. And let's not forget the c, but we did prove what we set ourselves to do, the fact that integral of secant of x dx, it's ln of absolute value of secant of x plus tangent of x plus c.